solving linear inequalities. So an inequality is when things aren't equal. And if they aren't equal, they're either going to be greater than or less than. Or they could be greater than or equal to or less than or equal to. But remember that if we write 2 is less than 3, that we can always flip that around and say 3 is greater than 2. These are the same. And by the way, if I say 3 is greater than or equal to -5, it's greater than or equal to -5. You don't need the equal, of course, but it's not wrong to put it there because that's still a true statement. And I can flip that around and say that that's -5 is less than or equal to 3. And again, these are the same, which means that when I say x is greater than -7, that I can always flip that around and say -7. Notice I'm keeping the point towards the -7 is less than x. And again, these are the same thing. So you got to get used to that. I always like to keep the variable on the left side. However, notice how the open side is towards the x. That's x is greater than -7. Down below, it's still the same thing. And when you read your answers, you read them from the variable. So even below, I would read this as x is greater than -7. And if you say -7 is less than x, that's perfectly okay. It's just not my preferred way of doing that. So over here, if I say y is greater than or equal to -6, again, I can flip that around, keep the point towards the 6. I can say -6 is less than or equal to y, but when I read my answers, I always read it from the variable. It's y is greater than or equal to 6. The open side is the greater. So if I graph these, if I go below and graph x is greater than -7, you have to remember that it's greater than -7. So I'm going to start at -7. I put that right in the middle of my number line. Smaller numbers always to the left on the number line. Smaller numbers are your negatives with bigger numbers on them. I start off with an open circle, and remember that you're going to shade solutions. Well, is -7 greater than -7? No, it's not. It's equal to. So it's not a solution because it's not greater than -7. The numbers greater than -7 are towards the positives. That would be on this side of the line. For the next example, y is greater than or equal to -6. Again, take -6, put it right in the middle of the number line. And start off with an open circle. Is -6 greater than or equal to -6? It's equal. So I'm going to shade it because it's a solution, and greater than numbers are again towards the positives. More examples of graphing. If x is less than or equal to 2, I start off with an open circle. Is -2 less than or equal to -2? It's equal, so it's a solution. We shade a solution. So solid dot, we fill that thing in. Basically, if there's an equal, we fill it in. Less than numbers are towards the negatives. Smaller numbers are always to the left on the number line. X is less than 2. Same thing. Only difference is it's not going to be equal to because 2 is not less than 2. So it's an open circle in this case. Same graph. X is less than 2, shade to the left. X is greater than or equal to 3. So it can be equal to 3. So we'll take our 3 and we'll put a circle and fill it in. Greater than numbers are to the right. Didn't leave a lot of room here on my number line. So these are all the numbers greater than or equal to 3. If there's an equal to, fill in your dot. If there's no equal, it's an open dot because that number would not be a solution. Now, you'll notice that I only have 3 examples here. And that's because the only difference between an inequality and an equation is that if you divide by a negative or multiply by a negative, you have to flip the sign. And the reason for that is because if you're dividing by a negative and the top number is negative, that two negatives makes it a positive, and which completely makes you flip the sign to keep it a true statement. So because dividing by a negative changes the sign, essentially, if it's a positive, it becomes a negative. If it's a negative, it becomes a positive. Dividing by a negative changes the sign. It forces you to flip the sign to keep your statement true. Example of that is over in the corner here. -8 is less than 4. We all agree with that. If I divide both sides by -2, notice how dividing by a negative changes the sign. You get +4 is less than -2. 4 is not less than -2. So what you have to do is flip that sign. So that must be flipped, and I get 4 is greater than 2. If you divide by a negative or multiply both sides by a negative, you have to flip the inequality sign. So these three examples illustrate that. Other than that, everything is exactly the same as an equation. I get the variable by itself using the inverse operation. So on this first one, what I'm going to do is subtract 6 from both sides. -6 minus 6. I get -3x is greater than or equal to -9. Notice I didn't flip the sign. It's only if you divide or multiply by a negative. That's because, again, dividing and multiplying by a negative changes the sign, the signs. So I'm going to divide by a negative, which changes the signs on both sides. I have to flip the sign. I get x is less than or equal to 3. So start off with your solid dot because it can be equal to 3. We're shading solutions. Less than numbers are always to the left. Now, not every question on here is going to ask you to graph. And that's the case of the next two. You don't have to graph. You just have to find the answer. But they both illustrate the negative idea. Get the variable by itself. Take an 8 off each side. Now I'm subtracting 8. I don't flip the sign. It's only divide and multiply because that's when those signs change. -10 is less than -2x. I'll divide by -2. I divided by a negative. That's going to change the signs. The -2 up top becomes positive 1x. So I get x, and the sign gets flipped because I divided by a negative. X is less than 5. Notice the way I read that. I read it from the variable. X is less than 5. Those are the same thing. Last example, I'm going to get rid of fractions. I'm going to multiply everything by my common denominator, common multiple of 7. Everything gets multiplied by 7. The 7's cancel. I get -28 is greater than -3x plus 56. I'll take a 56 off each side. And I get -3x is less than -84. And I'll divide both sides by -3. When I do that, I have to flip the sign because I divided by a negative. That changed the signs on both sides. So the sign gets flipped. And 84 divided by 3 is 28. So this is x is greater than 28. Those are the same answer.